Hello everyone, and welcome back to the podcast. Today is Monday, March 9, 2026. I'm your host, Anoani, and I am so excited to be here with all of you today. Today, we have a super cool topic to talk about from the world of machine learning and robotics. Imagine if you could teach a robot how to do chores, just by using your smartphone. Well, that is exactly what our paper today is all about. The title of the paper is RoboPocket. Improve robot policies instantly with your phone. You can check out all the amazing videos and details at that project page, which is at robo-pocket.io. And the paper is also on archive under the identifier 2603.0FF504V1. It is quite a long identifier, but the ideas inside are absolutely brilliant, so let us gather around and learn about the big problem these smart researchers are trying to solve. Right now, teaching robots how to do things is really hard. Usually, we use something called imitation learning. That means a human shows the robot what to do, and the robot tries to copy it. But to make a robot really smart, it needs tons and tons of data. And getting that data is like a huge traffic jam. In the past, people had to use big, heavy, and expensive robot arms to collect this data. Then, some clever folks made handheld tools, so you could just wave a stick around to record the movements. But here is the catch. When you are just waving a tool around, you are collecting data blindly. This is called an open loop system. You do not know if the robot actually learned the right lesson until you go back to the lab, put the data into the real robot, and watch it fail. And oh boy, robots fail a lot when they step outside of what they know, which is called a covariate shift. They get confused. To fix this, scientists use interactive methods, like one called Dagger. But Dagger needs the physical robot right there with you, which is slow, costly, and even dangerous if the robot bumps into things. This is where RoboPocket comes in to save the day. The researchers built a system that lets you fix the robot's brain instantly, without even needing the physical robot in the room. How do they do this? They use an everyday consumer smartphone, specifically an iPhone, as a super smart co-pilot. They call this robot-free instant policy iteration. Instead of just recording video like a normal camera, the iPhone uses its powerful computer chips to run augmented reality. This feature is called our visual foresight. Imagine you are looking through your phone screen, and you see a trail of virtual coins floating in the real world. Those coins show you exactly what the robot is planning to do next. If the virtual trail goes off the table or does something silly, you can see the mistake before it even happens. Let us dive a little deeper into how the magic happens behind the scenes. The system uses a remote inference framework. This means the heavy thinking is done by a powerful server over Wi-Fi. But it happens so fast that there is less than a 150 millisecond delay. When you see the robot making a mistake on your screen, you press a physical button to take control. You then show the system the correct movement. This new, correct data is immediately uploaded to a data serving node. Then, a training server does something called online fine-tuning. It mixes your brand new correction data with the old data, using a special weighted sampling strategy. So the robot learns the new trick without forgetting the old ones. Within a single minute, the updated brain is sent back to your phone, and the virtual trail of coins shifts to show the correct path. It is truly amazing. Let us also talk about the tool you hold in your hand, because it is very special. The researchers did not just glue a phone to a stick, they 3D printed a special grabber that perfectly matches the real robot hand, which is called a skeuomorphic adapted gripper. They even put a little spring inside it. Why a spring? Because real robot hands are a little bit bouncy when they bump into things. I put in the spring in the handheld tool. The data you collect feels exactly the same as the real robot. We also added a special fisheye lens to the phone camera. This makes the camera see really wide, so it can look at the environment and the gripper at the same time. To make sure everything works perfectly, the phone runs real-time checks on the movement tracking, warning me instantly if the camera loses its place. All of this only costs around $70 to print and build. Now, how would we use this amazing technology in our everyday lives? I have 3 wonderful examples to share with you. First, think about cooking in the kitchen. The paper talks about a task called seasoning pouring. Teaching a robot to grab a spice jar, rotate its wrists to pour, and put it back is super tricky, usually. The robot gets confused after turning its wrist, because everything looks upside down. With RoboPocket, The chef could take the smartphone tool into their own kitchen. They look at the screen, see the robot's virtual plan going wrong, and show it the right way to pour the salt. Because the update happens in minutes, the chef can instantly teach the robot how to handle all sorts of different jars and spices, right there in their own home. This means we could soon have helpful robots cooking dinner for us. Second, let us talk about doing the laundry. Nobody likes folding clothes, right? But researchers tested a task called towel folding. Cloth is really hard for robots to understand, because it changes shape every time you touch it. If you just collect normal data, the robot grabs the wrong corner and makes a mess. But using RoboPocket, you can see exactly which corner the robot thinks it should grab. If the virtual R shows the robot missing the corner, you step in, guide the gripper to the correct spot, and the robot learns the exact shape of that specific towel. In the real world, this means you could buy a helper robot, show it how to fold your favorite shirts and blankets using your phone, and the robot would master it almost instantly. It takes all the frustration out of teaching robots how to handle soft things. Third, this technology is going to change factories and grocery stores forever. The paper discusses a remarkable snack bagging task where the robot uses two hands, one to hold the bag and one to put the snacks inside. Normally, getting two robot arms to work together requires massive amounts of data. But the coolest part of RoboPocket is its distributed multi-device synchronization. That means you can have 4 different workers, and 4 different, all wearing these smartphone grippers. They can all look at their screens, find out where the robot is messing up, and send directions to the main brain at the exact same time. The paper showed that with just 12 little corrections from each person, the robot got 2 times better at sorting blocks. In real life, a grocery store chain could have workers across the country teach their bagging robots new items simultaneously. If a new brand of chips comes out, one worker scans and bags it with RoboPocket, and every robot in the world learns how to do it in minutes. That is just mind-blowing. To prove this all works, the team even tested the data scaling laws with a mouse arrangement task. They collected data across 64 different environments and object pairs. They found that as the data got more diverse, robot success rate shot up in a predictable curve. This proves that using normal people with smartphones is a perfectly valid way to build huge datasets for AI. To wrap up our lesson today, Robotics is a huge step forward for machine learning. By turning our smartphones into intelligent robot trainers with our feedback, we do not need to rely on expensive labs anymore. We are putting the power of a robotics expert right into everyone's pocket. It respects the data scaling laws, meaning the more diverse data we get, the smarter the robot becomes. And because it tells us exactly what data it needs, we can make our robots twice as smart with half the effort. I hope you all had as much fun learning about this as I did. Remember to always stay curious, and keep looking at how technology can make our everyday chores a little bit easier. Thank you so much for listening to today's episode, and I will see you all next time. Bye-bye.